Hello, everybody. Good day. Today we are going to talk about Newton's third law, and it is one of the very simple laws. Uh, to understand this law, let us start with the first simple example that you can see on your screen. That there is a hammer that is hitting the nail. So, whenever we apply the force of the hammer, so hammer applies the force. Likewise, hammer is pushing the nail downward and it's applying the force. In the reaction, the nail also pushes the hammer upward. That's why when you hit it hard, so it starts slowing down and hammer stops. So the force applied by hammer on the nail is balanced by the force of the nail on the hammer, due to which nail reduces the speed to 0. So I can use the word the force which we applied, or the force of the hammer, is actually the action, and which is on the nail, and on the opposite side there is a reaction of the nail, and this reaction is opposite. So what Newton told us the same thing. He said that very simple wording is, to every action, to every action, there is there is an equal an equal reaction. So what we found here, according to Newton, in this example of the hammer and nail, so the hammer is applying a force. Action is actually a force. So action of the hammer is balanced by the reaction of the nail. So both of the action and reaction, according to Newton's third law, are equal but opposite in direction. That you can see that action is going down and reaction is going upward. So action and reaction are equal but opposite. This is very simple example. So the secondly, if you have another example like I have here, if I show you by the example, this is a boy that is uh, uh, someone is moving the boat. When this someone is moving the boat, so how the boat is being moved? Because of this stick, it's pushing the water backward. So this backward push, backward push with the boat stick, backward push is the action. And due to this action, there is an equal reaction on the boat. That equal reaction is on the boat, and due to which this boat is moving forward. So forward reaction. So what we found, that this action makes the boat to move in forward direction. So action and reaction, again we can see, are acting. So both forces are making possible for the boat to move. Similarly, if we move here, that there is a boy or a man which is trying to jump from the boat to the dock. So when he's trying to jump, actually what he's doing, he's pushing backwards the boat, pushing back. the board. So when he is pushing back the board in the as an action, so in the reaction, what is happening? That the board is applying an equal force in opposite direction. That's why it the man is moving forward. So this is moving or jumping on the dog. So moving forward because of this reaction. So this will also be carried out as reaction. So what we found here in all of these three examples, that every action that we do has an equal but opposite reaction. Similarly, if we see on this example of the ice skater, this is an example of the ice skater. This ice skater, what she is trying to do, she is trying to push the wall. When she is trying to push the wall on the right side, in the reaction, this is the forward force of push. This is the action. And in the reaction, the wall is sending her in backward direction. This is the reaction. So we can also see why whenever she is applying more action, more force on the wall, she will exhibit the similar type of reaction, similar type of force, similar amount of force, and she will go backward quickly as as a reaction. On the other hand, if I try to focus here in another example, there is very simple example. For example, if you have seen the motion of a rocket, that we call how the rocket moves inside the atmosphere, how the rocket is being propelled, so you can easily understand that rocket propels because of the Newton's third law. How? If you just look at here, rocket has the gases that burn while it is moving. So these burning gases are pushed from the rear side downward. So this downward push of the gases is an action, and in the reaction, the gases make on the rocket, that in the reaction, the rocket moves upward. So as the gases will move faster, more gases will move faster, more will be the reaction, and the rocket will move further. Similarly, bacteria propels through the liquid in the same way that from the rear side it pushes as an action water backward, and in the reaction it moves forward. So these are the simple examples of Newton's third law. Now, what we found from the Newton's third law is that is very important. So from Newton's third law, we found three important things. Number one is that to every action there is a reaction. So we can just say action is a force that has a reaction that is also a force. So action and reaction are always side by side. Okay, this is the first thing. Secondly, action is always equal in magnitude in the value to the reaction. The as much force you will apply on the wall, the wall will give you that much force in return. If you push the corner of the table on your hand with your hand, so you will feel a little pain. But if you push harder, your action is having more force, so in the reaction you will feel more pain, so that will give you same type of reaction. So action and reaction are equal. And the third thing that is very very important, action and reaction are on the two different objects. Action and reaction are on the different objects. Reaction are on different objects. This is very important thing to remember. Action and reaction are equal, but they act on the different objects. How the different objects? Let me show you from these example which I already explained. For example, when we talk about in the first one that there is hammer is applying a force of action. So action is by hammer. Action is by hammer on nail. So action is by hammer on nail. But when you talk about reaction, reaction is by nail on hammer. So you can see the action was on the nail, but the reaction is okay. Now we will understand how to name these action and reaction forces uh, mathematically. First of all, these action and reactions are, forces. So let us start the method first of all. So whenever these are forces, so we will mention each of them as the letter F. Okay. Now, even it is action or reaction, you have to write it as F. This arrow shows that F is a force and force is a vector. Now you need to write two subscripts here at the lower side of the force. So these two subscripts are showing that where you have to apply the force and by which object you have to apply this force. So whenever you have these two subscripts, so you need to write the first subscript as upon which the force is being applied. For example, if I will choose the first subscript, so I will choose this subscript that action is on which object, and the second subscript I will choose by which subject this action is applied or which is actually applying the force of action. So in this case, in the hammer and the nail, you know that the action was uh, applied by the hammer on the nail. So in that case, what I can say? I can say action is a force that is applied on the nail. So I cannot write full letter for the nail. I will just write the letter N, the first letter for the nail. So I will choose force of action is on the nail. So I will choose N on the nail by the hammer, and for the hammer I may choose H. So the action is force by hammer on the nail, so I can write it F and H. On the other hand, if I'm going to write for the reaction, so I can say force on the hammer by the nail. So it will become F and H. So here I can say, according to Newton's third law, as action of hammer on the nail, F and H is equal to the reaction of the nail on the hammer, FHN. So I will write mathematically action and reaction are equal, but I have to put a negative sign here that shows that both action and reaction are equal, but they are opposite in the direction. Similarly, if you look at here on the skater, so this person is applying force on the wall. So as an action, I will say force of person on the wall. So it is on the wall. For the wall, I will use the W, and for the person, I may use P. So action is FWP, force on the wall by the person. And as a reaction, I can say force by the wall on the person. So force on the person, I will choose P first, and then by the wall, I will choose W for the wall. So mathematically, I can say force of action from the person on the wall, FWP, is mathematically equal but opposite to the reaction of the wall on the person. So I'm repeating one more time. For Newton's third law, every action and reaction are equal but opposite in direction, and they are working on two different objects. So just think of another example and give me a mathematical uh, equation for that, like this one. Action of gases on the rocket. So I may write this action as force of rocket, or force by the rocket on the gases. So I will say GR. In the reaction, I will say force of gases on the rocket. So FRG. And mathematically, if I try to develop the equation, I can say FGR, that is action of rocket on the gases, will be equal but opposite to force of gases on the rocket, and it is in the opposite direction, and it is making the rocket to propel in the air. So that was all about our lesson of Newton's third law. And I will just remind you that Newton said, to every action, there is equal but opposite reaction. Action and reaction are equal, but they act on two different objects. To write an action, you choose the letter F with the subscript uh, by the object, and on the object use one alphabet letter for them. So if you walk on the ground, so you are applying force on the ground. So force by the person on the ground will be FGP, which will be equal to FPG, that is force of the ground on the person in opposite direction. Thank you so much, and bye bye for now.